So let's have a look at how to draw a velocity time graph. So let's take a simple enough scenario where we've got a person standing on the top of a cliff, and this person is going to throw a stone upwards into the air and then let that drop back down again and into the ocean, which is farther away. So farther below them. So obviously, as the person releases this stone, it's going to be released with a particular velocity. It won't be zero, it'll be some other value, it'll be a high value. That they release the stone upwards, it'll get to some peak up here, and then it'll turn around and go back down again, picking up speed as it's coming down the way, and eventually crash into the ocean. Alright, so what I would expect you to do now is take out a sheet of paper, pause the video, and have a go at drawing the velocity time graph yourself, or sketching it. This is only a sketch, it's going to have no values on the graph, so it's just a case of sketching out what you think the velocity time graph will look like in this scenario. Okay, so you can pause the video now. Alright, let's have a go at kind of breaking down this motion into different parts and see if we can draw the velocity time graph. Now, the first thing that we have to do with this is we have to select which is a positive direction and which is a negative direction for our velocity time graph. Essentially, our graph is going to look something like this. So we're going to have velocity on the y-axis, we're going to have time on the x-axis, and we're going to have a positive velocity depending on the direction that the stone is traveling, and a negative velocity depending on the direction the stone is traveling. And that depends on how you set up your kind of how you set up which is positive and negative. For the purposes of this video, and it doesn't really matter which way you pick, it's all the same, I'm going to take it that this direction is positive. This is a positive direction, so upwards is positive, and anything downwards is negative. That means that any acceleration in this direction, any velocities in this direction, anything like that are going to be negative on our graph. Any kind of displacements, velocities, accelerations in this direction going up the way, they are going to be positive. We're going to consider those to be positive. So let's look at the first part of the motion. That is from the person's hand up to the highest point up here. Now, first of all, when the person releases the stone, it's not at a zero velocity. It's at some large value of velocity. It's going to have a high speed when it leaves the person's hand, the speed that the person's hand is moving at. And this is going to be non-zero. It's going to be a high value. And it's in this direction, it's upwards, and upwards means that it's positive. So it's going to start with a large positive velocity, leaving the person's hand, right? Now up here, it'll as it travels up the way here, it's going to slow down and slow down and slow down and slow down, and eventually, just momentarily, it's going to come to a stop at the top here. So once it's released here, a high positive velocity, and this will reduce and reduce and reduce until it gets to zero. So let's put that part of the motion onto our velocity time graph that we have on a different sheet. And I'm going to I'll draw this in blue. So we're going to start with a high positive velocity up here. And this is going to reduce, I shouldn't have done it like that, I'll do it with a line. So this is going to reduce uniformly to zero. Now it's going to reduce uniformly to zero. Why is this uniform? Well, we're going to assume that there's no air resistance or anything like that, that it's just due to kind of the gravitational pull on the stone that it's slowing down. Nothing else, no other forces acting. Alright, so that's the initial part of the motion. We said it starts with a high positive velocity and decreases until it gets to zero. Now, let's look at the second part of the motion. The second part of the motion starts here. Now, it starts from a zero velocity. And it will speed up, the stone will speed up as it travels down in this direction. So it'll speed up as it travels in this direction, and just before it hits the water, it'll be at a kind of a maximum velocity. Now, that maximum velocity is going to be bigger than the velocity that the stone got released with here. If you look at it, if everything was perfect and you had no air resistance or anything like that, if you released the stone with a certain velocity u here, it would travel up to the top, it would stop up here, and it would come back down here, and as it got down to this point again, it would now be traveling at u in that direction, in the downward direction. And then it's still increasing in speed as it drops down here. So this velocity down here is going to be bigger in magnitude than the velocity that the stone was released with here, but it's going to be in an opposite direction. This time the stone is moving in a negative direction. So it's starting at 0 and getting more negative and bigger negative values as it's going down here until just when it hits the water. So let's put that in on our graph. So we're starting from 0. We're starting from 0, and because we're traveling under gravity still, we've got the same acceleration but in the negative direction now. And so essentially that is our motion for the second part. This is to make that clear when you're looking at it. This is, we can call this part A here, we'll call this B, and we'll call this part down here C. Now at this point, the stone hits the water. We'll see what happens then at that point. If we were to take it that it completely stopped, we'll put that in on the graph as well, just so that people have an idea. So if we're to draw those parts of the motion in here, well, this is A here. This is where the stone is released. This is B, where the stone kind of momentarily comes to a stop, and then this is C down here, where it's just about to hit the water. And if we wanted to, we could put a D point down here. It's just as soon as it hits the water, essentially we're going to say that the stone has stopped completely, right? Has stopped completely. And so that happens very, very abruptly in a very, very short space of time. So essentially what happens there is something like that. So not quite straight up because it doesn't happen instantaneously, but very, very quickly this comes to a stop in a very short space of time. This negative velocity just goes to 0. And so this is D here. D. Not drawn very well. This is D here at this point. Okay? So that's analyzing a velocity time graph. To review, what you do is you break up the motion into the different parts. You look at kind of the start and end of each piece of the motion, and you can kind of mark those on the graph, and then just fill in the lines in between essentially. Leaving with a high velocity, going to 0 at its highest point, then starting at that 0 and increasing in speed but in the negative direction until it gets to the point where it's at its highest speed just before it hits the water. And then we can say it hits the water and basically comes to a stop, so it goes to 0 velocity in a very short space of time, so only a small amount of time has passed. And that's our velocity time graph.